Welcome to Digital and FinTech Analytics channel.
Hello friends, welcome back. In this video lecture, we will be exploring the insights from the collaborative filtering. So what happened until the last previous lecture video is like you for each of the test users or the well user. Here like the test users and well users are kind of the same, but in the real world like the test users and validation users are different. But for the sake of simplicity, I have taken like the test users as well as the validation users as to be the same. So like for each of the test and well users, what we do is like we create a personalized profile vector. So a vector that represents their purchasing pattern from like the personalized point of view. Similarly, for each of the train users, we are creating that personalized profile vector uh, from their personalized insights point of view. Now, in collaborative filtering, what we will do is like the aim of this collaborative filtering is like for each of the test users, we need to figure out who are the users in the training data set who are having similar kind of purchasing pattern as compared to the test users. So for that, what we do, so we will train our nearest neighbor model on the training users. So basically, for corresponding to all the training users, we will be having, so say like we have like 100 training users. So corresponding to the 100 training users, we will be having like 100 personalized profile vector. So we will pass this 100 personalized profile vector, these vectors into this uh, sklearn nearest neighbor model, and the model will understand the training user data set. And when we'll pass any of the users from the test data set, it will recommend us the top 5 users from the training data set who will be having similar kind of purchasing pattern as compared to like this test user. So corresponding to test user one, select test user one, we'll be getting like the top 5 users from the trained data set who have similar kind of purchasing pattern, similar purchasing pattern as of test user one. So that's the purpose of this uh, nearest neighbor model. Now let's look into the code point of view how this works. So yeah, earlier we had created like this finalist vectors, which is like the personalized profile vector for each of the user. And now what we do is like we take for the training users as well as for the test users, we will take their user id and the finalist vectors or like the final purchasing profile vector for each of the user, and we will convert the purchasing profile vector corresponding to the training users into a list, which is a list of list. And similarly we'll convert the pattern purchasing profile vector for each of the test users into a list of list. So these are like the purchasing profile vector corresponding to each of the user ids in the training data set, and this is the purchasing profile vector corresponding to each of the user id in the test data set. Now what we do is like uh, we create a list where like we will be saving all the purchasing profile vector corresponding to each of the train user, and similarly we'll be creating a list which will be saving all the purchasing profile pattern vector for each of the users in the test dataset. So the length is like 100 because we have like 100 users in the train dataset and we have 100 users for the test dataset. Hence 100 profiling vector for the test dataset users and 100 profiling vectors for the train dataset users. Now what we do is like we create a mapping. So for the test dataset, what we are doing is like we are creating a dictionary where like the keys are the user ID and the values are the uh, purchasing profile vector for those respective user ID. Similarly, we do it for the train users also. So the length of each of these is like 100 because we have 100 users in the test data set and we have 100 users in the train data set. Now what we do is like this is the most important part. So here we are. training a nearest neighbor model. This has been imported from sklearn sklearn package. So we are training a nearest neighbor model on our training dataset. Basically, we are training a nearest neighbors model on the purchasing pattern profile vectors of the training users, and we are testing it on the test users. It takes each of the profile purchasing profile vectors of the users in the test dataset, and will find the nearest neighbor. Nearest neighbor means like 5 nearest neighbor in the training dataset. So if you see, it returns two things: distances and indices. So distances, if you see, like it returns like for 100 users, what are the 5 nearest distance in the train user. And from indices point of view, it says like for the for each for the 100 users in the test dataset, who are the top 5 users in the test data train dataset that are very close to the users in the test dataset. So if you say like pass indices of 0, so that means like corresponding to the zeroth id in the test dataset, which IDs are closest in the training dataset. So you see like corresponding to the zeroth ID, we see like 68, 26, 95, 969, and 49. These are the IDs that are close to the zeroth ID in the test user. So we did that thing on a full scale level. So basically what we did is like for every user in the uh, for every user in the test dataset, what are the top 5 users that are closest to them from the training dataset. So that's what we see over here. For the user 10045 in the test dataset, these are the users that are closest to their purchasing pattern. From the purchasing pattern point of view, these are the users that have similar kind of purchasing pattern as compared to the user 10045 in the test dataset. Similarly, for the user 10046 in the test dataset, these are the users that are having similar kind of purchasing pattern in the training dataset. So we get that thing for all the 100 users in the test dataset.
That's a wrap for today's video. If you found this content valuable, make sure to hit that like button and subscribe to the channel so you don't miss out on future insights into data science, AI, machine learning, and analytics. Looking to master data science or drive data-driven success? I offer expert training, mentorship, and consultancy for individuals and organizations. Let's collaborate. Reach out via my contact details in the bio.